welcome everyone to the world of science. My name is Sadarsh and I'm here back again with a brand new topic, the dark matter. It's fascinating as it sounds, the dark matter. So, let's just get started. So, we don't need extra dimensions or parallel universes to have an alternate reality superimposed right on top of our invisible matter is everywhere. For example, take neutrinos generated by the sun, says Jesse Sheldon, a theorist at the University of Illinois at Urbana-Champaign who works on dark matter physics. He says, we are constantly bombarded with neutrinos, but they are passed right through us. They share the same space as our atoms, but almost never interact. As far as scientists can tell, neutrinos are solitary particles. But what if there is a whole world of particles that interact with one another, but not with ordinary atoms? This is the idea behind the dark sector, a theoretical world of matter existing alongside our own but invisible to the detectors we use to study the particles we know. Dark sectors are by their very definition built out of particles that don't interact strongly with the standard model. Sheldon says, the standard model is a physicist's field guide to the 17 particles and forces that make up all visible matter. It explains how atoms can form and why the sun shines, but it cannot explain gravity, the cosmic imbalance of matter and antimatter, or the disparate strengths of our nature's four forces. On its own, an invisible world of dark sector particles cannot solve all these problems, but it certainly helps. The main selling point for the dark sector is that the theories comprehensively confront the problem of dark matter. Dark matter is a term physicists going to explain bizarre gravitational effects they observe in cosmos. Distant starlight appears to bend around invisible objects as it transverses the cosmos. The galaxies spin as if they had 5 times more mass than their visible matter can explain. Even the ancient light preserved in cosmic microwave background seems to suggest that there is an invisible scaffolding on which the galaxies are formed. Some theories suggest that the dark matter is simple cosmic debris that adds mass, but little else to the complexity of our cosmos. But after decades of searching, physicists have yet to find the dark matter in a laboratory experiment. Can you imagine that? Maybe the reason scientists haven't been able to detect it is that they've never been underestimating it. There's no particular reason to expect that whatever is going in the dark sector has to be as simple as our most minimal models. Sheldon says, after all, we know that our visible world has a lot of rich physics, photons, electrons, protons, nuclei, neutrinos, and all critically important for understanding the cosmology of how we got here. The dark sector could be a busy place as well. According to Sheldon, dark matter could be the only surviving particle out of a similarly complicated set of dark particles. It could even be something like the proton, a bound state of particles interacting via a very strong dark force, or it could be even be something like a hydrogen atom, a bound state of particles interacting via a weaker dark force. Even if terrestrial experiments cannot see those stable dark matter particles directly, they might be sensitive to other kinds of dark particles, such as dark photons or short-lived dark particles that interact strongly with the Higgs boson. The Higgs is one of the easiest ways for the standard model particles to talk to the dark sector, Sheldon says. As far as scientists know, the Higgs boson is not picky. It may very well interact with all sorts of massive particles, including those invisible to ordinary atoms. If the Higgs boson interacts with the massive dark sector particle, scientists should find that its properties deviate slightly from the standard model's predictions. Scientists at the Large Hadron Collider are precisely measuring the properties of the Higgs boson to search for unexpected quirks that could open a gateway to new physics. At the same time, scientists are also using the LHC-2 Large Hadron Collider to search for the dark matter particles directly. One theory is that at extremely high temperatures, dark matter and ordinary matter are not so different and can transform into one another through a dark force. In the hot and dense early universe, this would have been quite common. But as the universe expanded and cooled, these interactions froze out, leaving some relic dark matter behind. The energetic particles collisions generated by the LSE imitate the conditions that existed in the early universe and could unlock dark matter particles. If scientists are lucky, they might even catch dark matter particles metamorphosing into ordinary matter, and even that could materialize in the experimental data as particle tracks that suddenly appear from no apparent source. But there are also several feasible scenarios in which any interactions between the dark matter and our standard model predictions are so tiny that they are out of reach of modern experiments, according to Shelter. These nightmare scenarios are completely logical possibilities, and in this case, we will have to think very carefully about astrophysical and cosmological ways to look for the footprints of the dark particle physics. Even if the dark sector is inaccessible to particle detectors, but dark matter will always be visible through the gravitational fingerprint it leaves on the cosmos. Gravity tells us a lot about how much dark matter is in the universe, and the kinds of particles interactions and the kinds of particle interactions dark matter particles can and cannot have. Sheldon says. For instance, more sensitive gravitational wave experiments will give us the possibility to look back in time and see what our universe looked like at extremely high energies, and could maybe reveal more about this invisible matter living in our cosmos. So that's it for the day. That's what I know about the dark matter. I share it to you, and this YouTube channel is a platform for me to share my ideas, what I know, share my information, share my knowledge to everyone else. So thank you for subscribing, thanks for liking, and thanks for sharing this video.